Hi guys, welcome to my most tutorials. Today we are looking at acids, bases and salts. Starting with the acids and bases. My apologies to the noise that's taking place. Unfortunately, I couldn't get a quieter place, but I hope this video is going to help you guys, and I also hope that Facebook and YouTube, they're not going to mute me. I don't own any rights, any copyrights to the music on my background. Okay, so now for today's business, we're looking at pH, which is the power of the concentration of hydrogen ions. So P is for power, H is for hydrogen ions. To say the solution that we have, how much of the hydrogen ions do you have in your solution, right? So the more acidic a solution is, it means that you are having a larger concentration of the H plus ions. It means you are having more of the H plus ions, right? For the alkalis and the bases, these ones they release hydroxide ions, which especially when they react with water. So these OH minus ions, they make them to be more alkaline. They form what we call alkaline solutions, right? So the higher the concentration of the OH minus ions you have, you say you are an alkaline. The more H plus ions that we have, we say that you are an acid, right? So the pH scale, it is just a numerical measure of the relative acidity or alkalinity of a substance. It determines whether it tells us whether what we have here, is it an acid or it's a base, right? So for the pH that is lower than 7, the lower the pH, the more acidic a substance is. If your pH is less than 7 and it's closer to a 0, it means that we are having a very strong acid, right? If your pH is close to 0, it means we are having a very strong acid. And if the pH is close to 7 there, it's way closer to 7, it simply means we are having a weak acid. 7 is neutral, meaning to say the amount of the H plus is exactly equal to the amount of the OH minus, right? The hydroxide ions that give us alkaline solutions in water. So when we look at the base side, the alkaline side, from 6 to 10, we can say those are weak bases. From 11 to 12, those are strong bases. So they become stronger and stronger as they reach 14. They become weaker as they reach 7. Same applies to acidity. Acidity, it's stronger as you reach towards 0, and it's less strong when you reach the neutral point, right? So with that being said, we talked of the neutral point. We said it's neutral at 7, at a pH of 7. What is neutralization? So when we're talking of a neutralization reaction, we are talking of a reaction where the H plus ions, they combine with OH minus ions to give us water. I hope you guys still remember that water is H2O, right? So the H plus ions, they are combining with the hydroxide ions to give us water. So remember, and our water is going to be neutral. So as more and more hydroxide ions are added, the H plus ions are used up, and at the end of the day, we end up having water, right? So the acidity therefore decreases. Let's say we start off with an acid and we keep on pouring a base into our acid. That OH minus in the base will react with the H plus and give us water. So the more and more we get water, the more and more the acidity of that solution becomes less and less. It decreases, and the pH will go towards the neutral point, which is almost 7, right? So there are not only hydrogen ions and hydroxide ions present when an acid reacts. Take note of that. For example, in the neutralization of sodium hydroxide with hydrochloric acid, when we react our sodium hydroxide with hydrochloric acid, there are also sodium ions. Sodium ion from the alkaline and the chloride ions from the acid. And sodium hydroxide, it will have the sodium ions and the hydroxide ions. The hydrochloric acid will have the H plus ions and the Cl minus ions. So here it's not only the H plus and the OH minus ions that are involved in the reaction. We are also having the Cl minus and the sodium plus. So these two ions, they remain in the solution, and if the solution is allowed to evaporate, at the end of the day, we will remain with the sodium chloride, and that sodium chloride is going to be our salt, right? So the sodium plus ions will then react with the Cl minus ions to give us what? Sodium chloride. Okay, I hope you guys understood the neutralization. And then we move on to indicators. So an indicator is any substance that changes color according to acidity or alkalinity of the solution. It changes color according to the pH. You know, when pH less than 7, we're talking of acidity. When pH more than 7, we're talking of alkalinity, right? So we have a litmus paper, we have methyl orange, we have the phenolphthalein. So you need to know the color changes. You need to know that when we put a red litmus paper in an acid, what color does it become? When you put a blue litmus paper, what happens to it, right? So our litmus paper, it's red in acid, take note of that, and it is blue in alkali solution. Methyl orange, it's also red in acid but yellow in alkali, right? And then phenolphthalein, it's colorless, take note, but then in alkaline it's going to be red. So to master this, the litmus paper and the methyl orange, they are all red in acid. So the only thing that is not red in acid is the phenolphthalein. And what color is it? It is colorless, right? But then we have the alkaline, so it's blue, yellow, red. So this one you have to cream it and